Okay, here's the second half of the assignment. We got these pipes and we got all these pictures that really, for everything, what we need to be able to do is deal with L. In class we use capital L, UT uses little l, which is pipe length. And we have to be able to relate that to lambda, which is wavelength. Okay, and it gets weird because when we're talking about lambda, that always means one wave. But in these questions, we don't necessarily have one wave. Now over here, we actually did have one wave. So lambda and string length instead of pipe are actually the same, but here that's not true. Okay, so what we need to do here is figure out how many waves we have in there. So we've got, each one of these is a half of a wave. So we've got, for my example, we've got 1, 2, 3, 4. All right, and then these on the end are each quarter waves. So I've got a quarter here, and I've got a quarter here. So I've got my 4 full waves in here, so I've got 4.5. So that means that the length of the pipe is equal to 4.5 lambda. All right, or if I write that in terms of just halves, I can say the length of the pipe is equal to how many halves? Well, that'd be 8 plus another 0.5, or 9 halves lambda. Okay. All right, so we want to determine the wavelength. So basically I need to solve this for lambda. So if I multiply each side by 2/9, like that, multiply this side by 2/9, I get lambda is equal to 2/9 times the pipe length. Okay, so let's look down here. 2/9 L. All right, would be the correct answer for mine. All right, you try it out for yours. Okay, number 10. Determine the wavelength of the sound wave in this pipe. So the difference here is at the end I still have a quarter wave, but at this end I've got a node and then a bunch of half waves. So I've got 1 lambda, 2 lambda, 3 lambda, and a quarter. So we need to determine the wavelength. Well, the length of the pipe is equal to 3.25 waves. Okay, so let's put this into not a mixed number, but just a fraction. So length, I've got 3 times 4, so I've got 12/4 here, plus another fourth, or 13/4 of a wave. Okay, so let's solve for lambda. I gotta multiply by the reciprocal, so I get 4/13 L is equal to my wavelength. Let's see if I'm right. Yep, there it is, 4/13 L. Okay. All right, the next one, we'll actually do this experiment in lab here. Okay, this time, instead of the wavelength, they want the frequency of the tuning fork. So what we're doing is we're playing a frequency, all right, a set frequency, it'd be labeled right here, and this pipe is resonating due to that. And you can change the water level to change the length here, but we want the frequency that's going to make that happen. All right, and it's got to be in terms of L and velocity of sound. So we're solving for this. Okay. All right, now this is one end closed, one end open. So we know for that if we're looking at F1 for the fundamental, we know that the length is equal to a quarter wave, 1/4 lambda. So let's zoom out a little bit here. Oh, I can't zoom out anymore. So this length right here, that's a quarter of a wave. All right, so again, like we did in the last two problems, let's rearrange this for lambda. So I can say that lambda is equal to 4L. All right, and the L is this open space of air up here. So 4 times that would be a full 1 wavelength. All right, so frequency, we know that V equals F lambda. And we want to solve for F. So we're going to say that F is equal to V over lambda. All right, now we got to think, all right, what is the velocity we're talking about? We're talking about Vs. Okay, that's given right here in variable form. Oh, sorry, I'm off the screen here. Okay, so again, we're doing V equals F lambda. Here it is rearranged. That's Vs, and then our wavelength is what we solve for right here in terms of the length of the pipe. So Vs over 4L would be our frequency. This is called the variables problem. It's where we solve for something like frequency in terms of other things without plugging in any numbers. We've got to get good at that. So here's the answer. Let's see if I'm right. Vs over 4L. There it is. Okay, last one. Okay, we've got a hollow pipe closed at one end, and we've got this length, and we've got a wavelength. Which one is going to schematically represent that wave, or which picture matches the situation is what they're asking here. Okay, so what I need to do again is relate pipe length to wavelength. So I'm trying to figure out how many waves I should be looking at. All right, so pipe length equals some number. I'm going to put an X here because I don't know how many waves. The length of the pipe is equal to some number of full wavelengths. Okay, and I know both of these, I just don't know the fraction here like I did in the other problems. So it's kind of, it's a different type of problem here. Okay, so let's plug in some numbers. The length of the pipe is 132.6. Okay, is equal to X, and then my wavelength, if I divided it over to the other side, I'd be dividing by 31.2. Okay, so let's get the calculator and divide that. 132.6 divided by 31.2, and I get 4.25. Alright, so 4 full waves, X equals 4.25. So that means I need 4 full lambdas and then 1 quarter lambda. So let's look at a picture that's got that. Alright, so number 3 is correct because I've got 1, 2, 3, 4 waves, and then a little quarter at the end. Alright, so there it is. Alright, hopefully that helped clarify those for everybody. And there you go. There's your homework. Alright, thanks for watching.